So welcome everyone to this evening's webinar on the building regulations. I'm delighted to welcome Marianne Heaslip of People Powered Retrofit to talk to us this evening. We're going to just spend 5 minutes with an introduction by me, Tina Holt, about CAFs, and then hand over straight to Marianne to talk about the building regulations update. At about 6:15 we'll stop for Q&A, and 10 minutes later we'll just do our feedback survey and thanks, and close hopefully promptly at 6:30. So corporate action for sustainability. If you haven't come across us before, we do a lot more than just building materials, building webinars, that kind of thing. Do go and have a look at our website, look at Zero Cumbria Partnership and Zero Carbon Cumbria Partnership and the other things that we're doing. Within the energy team, we run free and paid for services for householders. So do take a look there. There is quite a lot of free assistance out there, and obviously our paid services for people who've got retrofits on their mind or ambitious plans. So Marianne is a technical lead at People Powered Retrofit, and she has worked on their services, their retrofit, the home retrofit planner, the software, and has huge experience of designing retrofit projects, delivering retrofit projects, and has worked on some of the well-known projects from a couple of years ago, like the TSB Retrofit for the Future, and other work as well. And has worked on some pretty big scale social housing projects as well as just individual homes. So she's bringing a huge amount of experience to this webinar. So over to you, Marianne. I'll stop sharing and you can start.
I will share my screen now then. Thank you everyone for coming. It's quite a thing to spend a Wednesday evening talking about the building regs, but hopefully this will be useful. And hopefully you can still see that slideshow. Yeah. Great. So I'm going to be talking about the building regulations, specifically those regulations that are to do and how they're often managed and applied in retrofit. So we're talking about building refurbishment. We're not talking really about new dwellings. And I've really focused on the ones that were mentioned in some of the information around this. So it's Part L, which is to do with fuel conservation and power. Part F, which is to do with ventilation, and a little bit on Part O, even though it doesn't actually apply to existing buildings. But the thing about the building regulations is that they are all a little bit interrelated. So you have to think about things like aspects of Part B, which is to do with fire, at the same time as you're thinking about your window openings and ventilation, and things like moisture when you're thinking about and keeping moisture out of a building generally, when you're thinking about how to better insulate it as well. So I'm sure a lot of you are very familiar with what the building regulations are and what they're meant to do, but just in case not, usually it comes after you've done some level of planning on a project. If it's required planning permission, it normally happens after you've got planning permission. It is an entirely separate process from planning, even though it is something that's often still dealt with by the local authority. It's really about the detailed construction of buildings. So it's about the materials and finishes that you use and the services and controls that go in them and how it's all put together at that construction level. A lot of the focus of the building regulations is on safety for building users. So it's really about making sure that when we're in our homes, when we're in our offices, schools, whatever, we're making sure that you're not going to get harmed by that building in the event of a fire or by something falling down or anything else. So that's a lot of what building control officers will tend to focus on. The emphasis on ventilation, things like ventilation and insulation, so Part F and Part L, is probably a slightly more recent thing, and especially in existing buildings. So it sometimes gets a little bit less attention, but I would argue it is also very, very important. It's enforced through the building control process, which involves plan review sometimes, but sometimes just an initial notice and site inspections, either from your local building control authority or from an approved inspector that you appoint to deal with that. But if you want to know more about the whole process and how it all operates, there's a really handy guide on that link. There's also a link at the end to the planning portal. And that's where all of the building regulations, the most current versions of them are all held. So hopefully that's pretty clear. The other thing that's probably worth me saying and being clear about is what we're talking about when we talk about retrofit. Really, we're generally, and I think CAFs are of a similar mind, we're talking about fairly significant upgrades to building fabric or building services to do with improving efficiency, reducing heat loss and reducing carbon emissions. So it's things like replacing the whole heating system or insulating walls or replacing windows. It's not just about kind of changing light bulbs. We're at a level beyond that. And that is why the building regulations start to apply and to become quite important. Also, just to say that the building regulations are getting better at this, especially with the most recent updates to Part F and Part L. But in any form of retrofit, we would always advocate for a whole house approach. That's something that acknowledges that homes are quite complex systems. You've got a lot of things going on, moisture and air movement and heat loss and building services and systems all interacting. And we'd argue that because of that complex context, you need a kind of risk management approach to that, which if some of you have come across the PAS 2035 standard, that's something that encourages. At the moment, that's only applicable in publicly funded projects, but a lot of the principles in it, I think, are really good. I think it's just about really being aware of potential unintended consequences and thinking about what you're going to do and how it's going to impact on what's there at the moment and also what might happen in the future and how different systems and bits of building are likely to interact. With the aim of making something that's kind of well designed, coherent, and performs well for the people in the home. I suppose the other thing to say is that a lot of the time when we're dealing with people who are asking for retrofit, it's going beyond just the minimum that the regulations require. I think the regs have got a lot tighter recently, so on things on U values, we might not go as far beyond them as we once did. But because people are doing retrofit for reasons that are about more than just regulatory compliance, it's about improving their homes in lots of other ways to do with comfort and carbon emissions and running costs. I think it's safe to say that a lot of the time you shouldn't just assume that the bare minimum to meet the regs will be what people actually want, but obviously we all need to be aware of that. And the regs really are, they're pitched at that kind of bare minimum. They're not in a lot of cases necessarily best practice. So that's just a bit of background context. To launch straight into Part L, which is the document, if we're talking about retrofit and energy efficiency, this would be the one that most people would go to first, I think. It's about the conservation of fuel and power. Really, it's talking about the standards of thermal performance that your building needs to meet. So that's things like the thermal efficiency of the walls, windows, doors, roofs, floors, but also the heating systems and controls, and how that needs to be considered as well. The current version came into force last year. There is a grace period. So if you've got a project that you are registered with building control before June last year, as long as you start building work before June this year, you can work under the old regulations. It is now a single document, so there's no more dividing between parts L1A and L1B. So that used to be new buildings and new dwellings and existing dwellings. They've kind of incorporated it all in one document. So it now covers both refurbishment and extensions, as well as new build. And you have to kind of go through the document to see which bits apply in your particular circumstances. Your building control officer should, or your approved inspector should be able to give you some advice on that. In this talk, because of the amount of time we've got, I'm going to be focusing on your renovated thermal elements. So that's things that already exist that you're improving, and new fabric elements. So they're, if you are building an extension, for example, and you've got a new wall, so it's the standards that that wall needs to meet, as well as some of the things that are kind of apply to the building as a whole. It's worth also saying that there are 2 different ways of complying with Part L. The first is elemental, and that's how all of the building regs used to be when I first started in practice. Pretty much, it was just you had to get that a particular wall or window or roof to a stated U value and services to a stated efficiency, and then you were compliant. There are some caveats and get out clauses, which we'll talk about in a bit, but that is still a way that you can approach things in an existing building. The alternative is to take a modeled approach. So that's, rather than considering the building as just a series of separate elements, you put them all together in a model that uses the standard assessment procedure in a process. So you would probably look to do this if you were doing a biggish extension. It's a process quite similar to new build. So you model the whole dwelling as one, and you have to meet a stated set of targets in order to demonstrate compliance. I'm not going to go into that in a huge amount of detail now, but if you wanted to speak to kind of a building surveyor, SAP assessor, they should be able to advise you more on that as well. The modelled approach, it is now in force using a version of full SAP called 10.2. But a word of warning that some of the software provided hasn't actually fully caught up yet. They've kind of implemented some modules and not others. So there is a little bit of confusion around that still. And then the other word of warning is the RD SAP, which is reduced SAP, which is the kind of reduced information version of SAP that's often used with existing buildings. If you kind of rent out a property, that's what would be used to generate your EPC. That hasn't been updated to SAP 10 yet, and it's looking like that won't happen until much later this year. If you do the same building in full SAP 10 and then do it again with reduced SAP, you will get quite different outcomes, especially when it comes to carbon emissions, because some of the values in SAP 10 for the carbon intensity of the grid are much more representative of where things are now, whereas the current version of RD SAP that's used to generate EPCs is well, getting up over 5 years old now, so a lot of the values in it are quite out of date. And that can affect things like heat pumps especially. So just a word of warning on that. If you do some work for someone and then they get their EPC at the end of it and it's not as good as what you thought it was when you were doing a full SAP calculation, that's one of the reasons why. The modelling can be really useful because it gives you more design freedom. This comes in especially in extensions where otherwise you might be limited in the amount of glazing you can have. It allows you to kind of trade off U values more. Just gives you that little bit more freedom, but obviously also takes a bit more work in the planning and the design of it as well. So just some things to bear in mind there. So, as I said, the other way of doing things is an elemental approach, and these U values actually apply in a way both to the modelled approach and to the elemental approach. They're kind of set as maximum values. In the modelled approach, it might be that sometimes you actually have to do slightly better than this if you're doing worse elsewhere, so you're having to engage in trade-offs. When we're talking about U values for new elements, and I'm assuming that everyone's familiar with what a U value is, but it's basically just a figure for the rate of heat loss through a building element. These are the values in the current version of Part L for new elements, new fabric elements in existing dwellings. So this is where you're building an extension, essentially, or adding a wall or adding a floor. Interesting that they've got swimming pool basin in there as a specific thing. That's not something I come across a huge amount of the time. The other time when these values would apply is if you're putting a new window in an existing opening, because they just treat any replacement window as a new fabric element. So those values have tightened up quite a lot. So the U value on a window is 1.4 now, and on doors it's also 1.4. There are some notes if you're looking at documentation about limits to that, and especially when it comes to historic glazing. So there are reasons why you might not be able to achieve that and justify that, which then calls for you to do other things like look at secondary glazing. But on the whole, that's the kind of U value that you should be aiming for. Also worth noting, it's the whole window U value, so it's the U value that includes the glazing and the frame and the spacer bars, so it's how it all fits together. Sometimes manufacturers and suppliers will quote the centre pane U value for the glazing, which would probably in most cases be slightly optimistic when it comes to what the actual U value is for the whole window, because the frame's usually the weakest point. But they're relatively straightforward, and they are not that far away from the requirements in new build now as well. So if you're building an extension, you're essentially building it to roughly new build standards. A quite different approach is taken when we're talking about renovated elements. So this is walls, roofs, and floors that already exist, but you're doing work to upgrade them. These are area weighted average U values, it's worth noting. So you can have bits of the wall that are slightly better, bits of the wall that are slightly worse. And there are also, as I said before, there are a few get out clauses that I've just basically copied over the text from the standard there. If achieving the U value is difficult, if it's not technically or functionally feasible, which is, there's a little bit of a judgment call as to what that means. And it might be something that in some cases you need to discuss with your approved inspector or your building control officer. Then it is possible to not use the improved U value, so the one in column B there. So for example, a wall would normally, unless you have a good reason not to, would normally be expected to achieve a U value of 0.3 or less. If it's not technically possible to achieve that, and also they do take payback into account as well, though how that is calculated is a little bit foggy in places, then you can say, actually, it's not possible for me to achieve that U value. I'm going to achieve a U value of 0.6 on that wall instead. That is perfectly acceptable, with the limiting factor being that you should at least be aiming for a U value of 0.7. So they do give you some leeway, and some of this will require a little bit of negotiation. The other thing, when they're talking about technical and functional feasibility, the other thing that they kind of sits alongside that, and it might be possible even to argue that a U value of 0.7 isn't achievable, is where you've got concerns about moisture. So interstitial and surface condensation is what they make reference to. But I'll go on. I won't read everything off here, but I'm sure you'll get the slides afterwards, so you can have a look at that in a bit more detail. The reason that last point is very pertinent, I guess, is that there are cases where people have just looked at the U value that they want to achieve and maybe not considered some of the other aspects of making buildings sound, which come under Part C of the building regulations often. And you end up with slightly interesting detailing. These are just some examples of some quite poor external wall insulation, but whilst notionally in a model, those walls might have met a required U value overall, I would argue quite strongly that they probably haven't complied with Part C of the building regulations because of the risk of moisture ingress, and also in some cases the risk of condensation, surface condensation, because you've got bits of missing insulation all over the place and poor cappings and things, which can have a really bad impact on people's quality of life. So we want to avoid that. So when we're talking about U values in retrofit, especially, we're talking about doing them with good quality detailing and also making sure that we're mitigating the risks of things like this happening. So some specific examples of limiting circumstances might be something like internal wall insulation, where to meet the 0.3 U value that's the target in the regulations might suggest that you use a higher performance, so, you know, a foam-based insulant, but actually, if you're working in traditional construction, especially, hygroscopic materials better. So that's people sometimes call those breathable materials. So they're materials that moisture can travel through, so it allows the wall to dry out, basically, is the main function of it. And those kind of materials are usually based on natural fibers, so things like wood fiber, sometimes hemp, that kind of thing. And they have notionally a lower K value. So if you just put it through a U value calculation, it will take more of that insulation to achieve the same performance. But actually, if we're also bothered about all of those other things to do with moisture management, it's better. There's a little bit of a benefit sometimes in thermal mass as well. So it's sometimes best actually to say, right, okay, on that wall, because I'm concerned about these moisture risks, I'm going to roll back a bit and not aim for that 0.3 U value and use a more appropriate material. Another perfectly good example of this would be where you simply don't have space to put enough insulation in. So if a staircase, for example, is against an external wall, you can't put so much insulation on there that the width of the staircase gets decreased and causes problems in terms of Part K and also Part B, means of escape. You can't narrow fire escape. So you're thinking about how all these things interact. On the converse, and I did mention before that, you know, people are often doing this kind of work not just to comply with the building regulations. If you're looking at something like external wall insulation and your roof's the right shape, or you can extend the roof to be the right shape and cover the insulation, then it's perfectly possible to go well beyond that 0.3 U value if you've got the space and the thickness, even using those kind of materials like wood fiber, which notionally are slightly lower performing when you look at the thermal resistance of them. And this is where the modelling approach, as opposed to the elemental approach, might pay off, because it means you can kind of reduce your insulation in those areas where you might be looking at internal wall insulation, but increase it potentially in other areas. The regs now do mention continuity of insulation, which is really useful. There's a much greater understanding now of things like thermal bypass and thermal bridging, It's not actually explicit in the regs in terms of the application to existing buildings, but I'd argue that it's very important and it's something you should pay attention to. It shouldn't just be that because you're working on an existing building, you don't need to worry about this stuff. And that's in part, again, because not just because of the effect on heat loss, which is the main concern of Part L, but also because of the risks that it does mention in Part L about condensation and mold. If you've got gaps in your insulation and you've got warm, wet air kind of flying through it to the outside, that's going to cause you problems potentially. The same goes for thermal bridging. There's a slightly more relaxed standard, I guess, in when it comes to existing buildings. It just says that care should be taken to reduce unwanted heat loss through thermal bridging. It doesn't actually set out a specific set of standards, but it does refer to some of the construction details library. If you go and look at that local authority construction details library, what you will notice though is that it's all for new build. There's very limited information in there at the moment for retrofit. So you can take some of the principles from it, but some of the details aren't necessarily directly applicable. So unless you've got a target Y value, so that's kind of the overall effect of thermal bridging on your home, unless that's stated and you've got a target that you're aiming for, a lot of the case in retrofit, it's about best endeavours. And that's even when you do have like a space heating demand target, or even when you're working in to the AECB standard or working to NFIT, it's about what's achievable given the circumstances. The best practice that we would often reference when it comes to thermal bridging isn't actually referenced in Part L that I can see at the moment, but in terms of existing buildings at least, but it is set out in the PAS 2035 standard. And essentially what that suggests is that you should achieve a surface temperature, internal surface temperature factor of 0.75 or greater, which sounds complicated, but basically all it means is that when you model your building in something like Therm, you set the internal temperature to 20 degrees, the external temperature to 0, as long as the surface temperature in your home at all locations is at least 75% of that 20 degrees, say, so at least 15 degrees, doesn't drop below that, then it demonstrates that the risk of surface condensation and mold is being minimized. So that's something to aim for. Though even then, especially if you're looking at phased retrofit, it might not be totally possible. So you do have to make judgment calls on it, especially when it comes to suspended timber floor junctions, I found. So you're insulating a wall, but you're not quite insulating the floor yet. It's not actually possible to achieve that, but hopefully you will in future. So, sorry, I am going at some speed here, but there's quite a lot to get through, so hopefully it's useful. Air tightness, again, in existing buildings, unless you've done modelling and you've got a target from your modelling, it's about best endeavours. The maximum value in new build now is 8 meters cubed per meter square per hour at 50 pascals. They sometimes call that the Q50 figure. The notional building, so that's the building that your building will be tested against, is actually 5 rather than 8. And what that means is that most of the time you'll only be able to achieve the overall energy performance targets if you get to that 5 or below, which is fairly achievable in new builds, can be a bit more of a challenge in retrofit. The other value that's mentioned there is to do with the pulse air testing, which is a kind of lower pressure thing, but I'll talk about that in a moment. Again, even though it's something that might not be, you're not necessarily given a specific target unless there's a project target, it's really important to pay attention to air tightness because of those moisture risks as well as heat loss. So that's just what it says at the moment in the standard, in the document about what we should be doing around air tightness in existing buildings. And it's just, a lot of it is just quite sensible. If you make a hole in the building in order to put a pipe through it for some new services, seal up the hole afterwards, or seal up any existing holes that you come across. And just make sure when you're putting in new doors and windows that they're all properly sealed and airtight. There is a relationship to Part F and Part J, but I'll come on to that in a moment. When we're talking about levels of airtightness as well, there's kind of different levels of work that you can do. This is a photograph from Jabez Mangwana, who some of you might know. He trades as Waxwing Energy. It's quite a lot of work involved sometimes in doing this airtightness, and that looks very neat, but it's not always possible to get things that neat. So this is insulating and putting airtightness membranes in under someone's floor and getting around a lot of pipe work. So it can be quite laborious, but I'd argue it's well worth it for those moisture risks. But also in this case, you know, somebody's floor, it's going to massively improve their levels of comfort. So you're going to end up with a much more satisfied resident who doesn't have drafts running around their feet. There's a little bit there about how we measure airtightness. Basically, the lower the score, the better. They do measure it slightly differently in Passive House and Enefit, and the standards are more stretching in Enefit than they are in the building regs. Really, in retrofit, we should just be doing as much as we can when we can. And one of the ways that we understand that is through doing some diagnostic testing as well. So this is, if any of you have ever seen it, that's Diane Hubbard, again, some of you might have come across, but doing a blower door test. So you put a fan on the front door, you pressurize and depressurize the house. And then quite often, if it's the right weather, you can use thermal imaging cameras to see where the drafts are going. If you do this before you do any work, it gives you an opportunity to see where the existing leaks are and where you can kind of fill them in. If you do it during, and usually towards the end of when your work is being done, it means that you can fill in any gaps, tape up any bits that you've missed before you put all your lovely finishes on. If you do it after, really all it's doing is giving you a figure to put back into your calculations, which is nice to know, but it's perhaps not as useful as the first two when you're actually planning and developing work. Yeah, quick note on Part J, which we also have to pay attention to when we come to making a house more airtight, especially. If you have gas fires, open fires, wood burners in a home, if they're not adequately ventilated, if they don't have enough supply air to generate good combustion, they are a risk to health. So we need to be really careful about that. Basically, if they're not burning properly, there's a risk of carbon monoxide poisoning. So that's what Part J goes into in quite a lot of detail. Ultimately, in more airtight homes, especially, but I would argue all the time anyway, there needs to be a dedicated permanent ventilation supply, separate often from the main ventilation system, to a fuel burning appliance. In theory, if you've got a small enough appliance and a leaky enough home, then you don't need to vent where air permeability is kind of higher. But that's something that really needs to be thought about quite carefully, because you might say, oh, well, I've got a wood burning stove. I'm retrofitting, but I'm only going to achieve an air tightness of 5.5. So it's fine. I don't need to do anything about that. But then you do all the work and accidentally it ends up at 4.99. Would leave you in a little bit of a pickle. Direct air supply is something that more and more wood burners and things are allowing for, either as part of a new installation, or you can get kits that you can retrofit to draw in a supply from directly from outside, so you're not using the air from the room for combustion. So that is one solution. Getting rid of fuel burning appliances is another, which I know in some rural locations, if you've got your own coppice you can go to, might not be popular, but it's something that probably helps a lot with air pollution and things like that as well. So I've got about 10 minutes left. We'll see if we can get through ventilation in 10 minutes. So part F is the part of the building regulations that covers ventilation. It now applies in refurbishment. It didn't, or at least not very clearly before. There was always a baseline expectation not to make matters worse, so not to kind of seal up a home and make it kind of unhealthy in terms of air quality. But now it's very, very clearly stated that that's the case. And that's to do with, I guess, increasing concerns around air quality. It's something that's in the news more and more. It's about both protecting building health and occupant health. So protecting building health because it's a way of removing some of that excess moisture that people kind of generate just by living in a home, by doing their laundry and showering. So it doesn't end up in the building fabric. And then occupant health because, you know, high levels of humidity are generally quite bad for people, especially people who might have things like asthma or allergies to dust mites, that kind of thing. So there are now much, much clearer expectations around when you should be upgrading a ventilation system in an existing building. Though I'd say that some judgment is still needed. And I think this is definitely one of those cases where the building regulations are a minimum standard, and we should maybe be looking to kind of go beyond that minimum standard in a lot of cases. It's useful in that to perhaps cross-reference with the past 2035 standard, which has sets out some requirements around a kind of condition assessment of ventilation. So it looks at, you might have a system in a house already that notionally complies with the regulations, but you go there and you find that actually there's a lot of condensation or a lot of mold. You can have take a judgment and say, actually, this system isn't performing as well as it should, and we might need to look at upgrading it. There's lots of useful resources on this kind of thing as well at the UK Centre for Moisture in Buildings, so I'd recommend just giving them a bit of a Google. Something that I think we all acknowledge is that the way that we ventilate buildings has changed. And originally there was open fires that would draw air through and slightly leakier fabric that would enable that. I'd say even in a lot of our older buildings where we've put in double glazing and we've put in laminate floors and things like that, the image on the right doesn't really apply anymore. And we need to think about ventilation, proper planned ventilation for that reason. This is what I was saying around there being a clearer expectation now of when you need to upgrade your ventilation system. So this is diagram 3.1 in the approved document. And it basically sets out a series of things that you might be doing to upgrade the energy efficiency of a property, whether the regulations consider that to be minor or major. And therefore, if you're doing a number of a combination of different measures, whether that means that you need to upgrade your ventilation system. And essentially that category A, category B, category C. Category A, so if you're only doing a couple of minor measures, then the regulations kind of consider that you might not need to do anything to the ventilation system. If it falls into category B, so you might be doing one major measure and a couple of minor measures, or then you have to carry out an assessment and you may need to upgrade the ventilation system. Category C, you're pretty much guaranteed are going to have to do something about the ventilation system because you've done quite a lot to the house. The argument being, if we're talking about betterment and not making something worse, the judgment that they've made in setting this out, I think, is that by the time you're doing 4 major measures and multiple minor measures, then you're making big changes to the the building that will almost certainly reduce the existing ventilation. The regulations are set out slightly differently now. So previously, a lot of it was set out as system-specific requirements. Now it's split out more so that you get the requirements to do with extract ventilation, cold dwelling ventilation, and purge ventilation, and then a set of system-specific information. So if people remember, there was like system 1, 2, 3, and 4. Something to note in that is that where there was passive stack ventilation there previously, that's not actually mentioned in the regs anymore. So it's only intermittent extract with natural ventilation, continuous extract, or mechanical ventilation with heat recovery. There are also some new requirements for handover information that suggest that you should have much clearer guidance to occupants on how to use ventilation and why it's important. I think that's because a lot of the time ventilation systems were maybe being installed without adequate information about how to control them and without an understanding of why you would want to. So then they maybe weren't getting used. So having that is useful. In order to do that, I'd argue that having a really clear ventilation strategy in the first place is key, because if you're not clear on it yourself, then you won't be able to explain it to someone else. And that's just a quick table of showing you what some of the ventilation rates are required. So for extract ventilation and for whole house kind of background ventilation, there's a requirement that you can just calculate in litres a second. It needs to be provided. Something just to take note of if you're replacing windows. So this isn't necessarily if you're doing anything to the ventilation system, but this is if you're replacing windows as part of the retrofit or refurbishment. There is now an assumption that trickle vents will be fitted in all new windows unless you say otherwise. So that really does mean that you need clarity for your ventilation strategy upfront in any phase retrofit, because what you don't want is to fit a bunch of new windows, have trickle vents in them, and then find that actually you want to do mechanical ventilation with heat recovery, which doesn't require those trickle vents, and those trickle vents will actually reduce its effectiveness and bypass it. And you need to kind of take those trickle vents out of windows. So it's just a need for clarity. I would also say that sometimes actually having wall vents as part of your ventilation system is better than triple vents in windows. They tend to be slightly more effective, partly because people don't cover them with curtains. I'd say that the only issue with them is that it can be a little bit ugly. So if someone out there would like to design some attractive looking internal wall vents, we'd be very up for that. I'd like to hear about it. Looking at the specific systems, so natural come intermittent extract ventilation. I think one of the really big issues with sticking with that system in retrofit is that the requirements for free ventilation areas in each of your rooms are quite large. It's practically twice as much in kitchens and habitable rooms versus what you would get if you went for a continuous extract. So by continuous extract, it just mean that extract fans are running at a triple level all the time rather than intermittent, which is where someone, actually switches a fan on for the length of time the bathroom light is on, or while they're cooking, or it's on a humidistat. There are also some questions about the effectiveness of intermittent vent. There are some articles written by Kate de Selencourt that I could recommend on this. I didn't manage to find the link just before the session, but definitely worth a read. I think there are definitely some questionable assumptions built into this around whether drafty homes, so homes that aren't very well draft proofed and airtight, haven't had a lot of airtightness worked into them. There's an assumption that that means that they're then well ventilated and the air quality is good, which I don't think it necessarily holds true. Continuous ventilation is where a lot of what we're doing in what I had been doing in social housing is going, rather than intermittent extract. It's really not much more complicated to install than intermittent extract, but reduced equivalent area of intakes, and also a little bit more effective. It can be either centralized, as is shown on the diagram there, or decentralized, so that's just individual fans in different rooms. I won't go into all of the complexities of mechanical ventilation and heat recovery, but it's worth doing if you can do it right. It is more costly, it's more complicated, it needs a lot of ductwork, so in retrofit, sometimes there just isn't the room for ductwork. But if someone's really concerned about air quality and noise and all of those things, it's worth considering. In all of these cases, you still need purge ventilation. Usually that's achieved with opening windows, and the regulations around the area of opening window hasn't changed. So it's a proportion of the floor area of the room, depending slightly on how the window opens. You can also achieve purge ventilation by having a boost on a mechanical ventilation system. And Part F is very clear that the standards stated here are to provide fresh air. If you're concerned about cooling for summer overheating, then it might be that a greater amount of ventilation, purge ventilation, is required. So finally, Part O. This doesn't officially apply to existing buildings, but I think should be a consideration in any retrofit plan. And that's especially the case if you talk to a householder and they say, actually, the front of the house gets really hot in the middle of summer, or the attic bedroom, I can't sleep in there, and in summer it's too much. Any existing issues like that are likely to be exacerbated by retrofit, so needs to be considered. And Part O, actually, maybe not necessarily in terms of the compliance and the way things are calculated, but in terms of the principles, it's definitely something that we should all be looking at, because it does ask that you consider not just how much ventilation is provided, but whether that's practical in terms of noise and safety, and how to integrate it with shading and things like that as well. What I would point you to as a slight alternative, given that compliance with Part O in existing buildings isn't strictly necessary, there's a tool that's been produced by the Good Homes Alliance, which is just a really simple add-up spreadsheet tool for assessing retrofit overheating in retrofit. And it's a list of about 10 or 15 questions. It'll allow you to highlight if there is a risk, and if there is a risk, you can investigate it further. But I would very much recommend that, and we use it for a lot of our projects.
We've got about 1 minute, Marianne. Is that all right?
Yeah. Very, very quickly. Final thing. Consideration of openings. It's often something that I've seen go slightly wrong in retrofits because it's not considered until the windows have been ordered. But the integration of Part O, K, B, and also F. So you're thinking about fire escape, ventilation, people not falling out of windows, and overheating, and sizing all your window openings appropriately. And in retrofit, it is possible to make adjustments often if you're changing things to do with the walls. It's worth doing. And then, Part B, please don't forget about it. It's something that we should consider in retrofit. We need to make sure that people can get out of buildings if there is an emergency. It's not the focus of this session. There's lots of other information out there, but please don't forget about it. And that's it. So all of the documents are available on that link. There's a lot of very good guidance as well. And that's been a bit of a whistle stop tour, so I will end there.
Builders, if you're interested in our retrofit work and our retrofit training, then do just either email us at retrofit@cafs.org.uk or fill in the feedback form, put your information, put your contact details in there, and say that you'd be interested in perhaps filling in our suppliers skills questionnaire. That tells us what you do, what work you can do, and if someone asks us for a builder in your area doing that kind of work, we can potentially put your name forward if we know that you're there and what you're doing. And if you want to go on more training days in person or webinars like this one, then also give us your details so that we can send out information to you from time to time. And also I would say sign up to the CAFS newsletter if you'd like to hear. We always put out our training of any sort on the newsletter, and remind people what's going on at CAFS. And thank you to those of you who donate when you come along to these webinars and make donations to CAFS. It's really appreciated. Everything, it means we can do more with what we've got, with the funding that we're given. But we can do extra if we've got the donations as well. So thank you so much to everyone for your questions. Thank you particularly to Marianne for sharing all that very valuable information with us. And thank you, everyone. It's been great to see you. It's been brilliant to have you here. And hopefully we'll see you again on another CAFS webinar at some point.